Good afternoon, uh, everybody. So, I like to start with a refresher what we discussed in our last video. We actually tried to define chemometrics. Not we tried, we just agreed that we will be using the definition given by the chemometrics and intelligent laboratory system. So, we stick to that. So there we saw that chemometrics is not just about analyzing the data, but it also helps us to design our experiments. Uh, and then we also talked like who introduced this subject. So it was Professor Savant Wold from Umeå University. He brought up this subject or this discipline at the higher education level, and now it's being widely accepted in academia as well as in industry, right? So that was a little bit about chemometrics in our last video lecture. So now the one question comes very naturally to us, like why chemometrics? What was the need of chemometrics? So this is like a fundamental question that strike everybody, right? We can analyze our data set uh, in our traditional way of analyzing it, right? So what was the need of doing this chemometrics or bringing up this new subject? So to appreciate the beauty and the magic that chemometrics bring to us, we could actually take a very fun or a very simple data set consisting of just 10 individuals, and we have their height and weight. So you see in the first column you have the subjects or the individuals. In the second column we report their weight, and in the last column we report their height. So this looks like any data set, and if we just gaze through this number, doesn't seem to provide any meaning, right? So then what we do, we actually take one of these variable and then make a plot. So we actually do the same here, and we make a plot. We just make a plot for height, and we make similar plot for the weight. So if I gaze through the height uh, describing plot, we see there are individuals who are as tall as 177 centimeter. There are some folks 160, one of the individual is close to let's say 168, some are 157. So nothing unusual, because as a human being you can have individual who who actually fall in this height, right? So there is nothing unusual we notice. Likewise, if we check the weight, there are some who are 62 kg, some are 50, some are 80 plus, some are 70, 68. So all these are normal human weight, nothing special. And if someone asks us to make some conclusion, we say we don't find anything, because usually human height and weight fall in this range. There's nothing unusual. But the moment you step out of this way of analyzing one variable at a time, or you step out of this traditional way of processing the data, and you go to a way where you analyze two variable at a time, or we go to multivariate analysis. So in this case, we analyze height and weight not in isolation, but in relation to each other. And how do we do this? It's very simple. You just make a scatter plot, and then your eye will see some magic happening. What it tells clearly that there is some sort of a linear dependency between height and the weight. As you grow tall, you carry some weight, you put on some weight, which is normal as when your child grow, as he grow tall, he also increase in its weight, right? So nothing unusual. And this relationship was not clear or not evident when we were analyzing two pieces of information in isolation. But when we put them together, or when we come to multivariate analysis, kind of analysis, we see this linear relationship. So that's fascinating, isn't it? Isn't it? We see something and we make some interesting finding. But then our eye also catches two subjects which are falling apart from this linear tendency. So there is one person who is 172 centimeter tall, so he is one of the tallest in the group. But you see, he just weigh 50. And then there's one guy who is 85 kg in weight and he's 158. So, when we were doing one variable analysis, we were missing these three conclusions: the linear dependency between height and weight, and then the two individuals that has unusual high BMI, right? So the moment we come to a more, you know, we come to a type of analysis where we try to put things in relation to each other, our understanding about the same data set changes drastically, right? So I hope you are able to appreciate the beauty of coming out of one variable at a time analysis to multivariate analysis. So this was just a simple example of two variable or two factors, right? Height and weight, and we make so much conclusion if we just plot them together against each other. We can make similar plot for if you have another parameter, let's say age. So you can also put that as a factor, and you can make three-dimensional plot, and then you can make similar conclusion if you have three factor. But the question comes when you have thousands of variable, hundreds of variables means hundred of factors, parameters, then how do you construct such high dimensional data set? How you make a scatter plot for those multi-dimensional data set? Because as a human, we can't put things or we can't visualize things that are more than three-dimensional in nature. So that's where chemometrics come into picture. Chemometrics help us to reduce, it help us to simplify the data set. So it will be, you will see in coming lecture how the chemometric methods identify new components from this multi-dimensional data set, and this multi-dimensional data set is reduced to much meaningful but way fewer in number, as minimum as like, or as less you can say as low as 3 2, right? And then again you can make a similar scatter plot with these two or three chemometrically identified components, and then your conclusions will be very similar to what we just saw with this scatter plot of height weight, right? So there's a lot of advantage, lot of power that chemometric methods give to humans when it comes to processing a high dimensional data set. So in coming videos, I will be talking a lot more how does chemometric reduces the dimension of the data set, how the new factors um, kind of take projection of these 100 variables, right? And help us to kind of come up with new conclusions. So all those things we will be covering. We will be touching upon how to do all those data reduction, projection by hand numerically with simple data set, and then you will really appreciate the beauty of all those things. So you need to stay tuned. I will be coming with new videos in coming days, and step by step we are building, right? We are building ourselves and to grow further in applying the chemometrics. So once we have a lot of understanding, the basic clear understanding of the advantages that chemometric bring to us, then we can apply this to any domain. So stay tuned for all those things. It will be coming in coming days. So with this, I like to thank you for your attention and hope to see you soon.